Hello, my name is METİN Arıdaşır. This is 197th part of explanation of my theory. Remember, according to my theory and my formulas, each continuous spectrum represents a specific wavelength, size, kind, free electron motion form that is in motion at a certain velocity as a light source. Here, lambda normal is equal to, say, 10 micron or 10,000 nanometer. Okay, starting point that. 10,000 nanometer. Okay, say this one, this is lambda normal 1. At a certain velocity, in motion and continuous spectrum, produces and propagates these electron motion form in motion, and this is continuous spectrum. This is, say, 2500 nanometer wavelength size, lambda normal 2, 2500 wavelength size. Okay, this is like this. This is, say, 1000 nanometer wavelength size electron motion from lambda normal, different size. Say for X-rays, okay, 0.122 nanometer wavelength size. Okay, continuous spectrum. Yes. Each continuous spectrum represents a specific wavelength size, kind, free electron motion form that is in motion at a certain velocity as a light source. There are different wavelength size, kinds, electron motion forms in our universes. Remember from my former videos, and remember, most common electron motion form wavelength size is 91.155 nanometer in all our atoms. Yes. Now think of, for instance, there are two different wavelength size free electron motion forms in two different motionless, star-like motionless object. Apart from them, say, $3,000 kilometers in universe. Here, a stellar object. Here, another stellar object. But imagine, they are motionless. Okay, motionless. Here, there are a certain type free electron motion forms. This is A, this is B. Okay. Here, say one group wavelength size is 2500 nanometer. Okay. Countless free electron motion form here, and they are in motion. They are at a certain velocity. Okay. And then, but object is motionless. Free electron motion forms are in motion. Star-like, we say. Star-like. You see, I hope you see. And here, think of, this is so important. There are 10,000 nanometer lambda normal, say 1, equal to 10,000 nanometer wavelength size, electron motion form, free electron motion form in motion, one group. Okay. Countless 10,000 nanometer wavelength size free electron motion forms are in motion at a certain velocity in this star-like object. But this is motionless. Okay. A certain distance, it's not important. Now, according to my theory and my formulas, remember hydrogen, Balmer series, Balmer lines in visible spectrum. Okay, say 410 nanometer. Okay. Here, visible band. Say between 390 nanometer and 690 nanometer. Okay. Spectra. Here, as a spike, 410 nanometer emission line of hydrogen. Now think of lambda normal 1 electron motion form 10,000 nanometer wavelength size, and think of it is in motion and it will involve this visible band. Okay, here visible band, and it will contain 410 nanometer hydrogen line. Okay. It is starting 10,000 according to my theory and my formulas, nanometer. Here, say 390 nanometer, this point. Shortened wavelength, okay. 3, I hope you see, 190 nanometer, shortened wavelength. Remember from my formulas. Lambda normal minus delta lambda. Okay, in this electrons, 10,000 nanometer wavelength size electrons, 0 degree motion direction. Okay, this is shortened wavelength, 390 nanometer. Now, according to my theorem, my formulas, I will compute. Lambda normal 1 minus delta lambda is equal to 39 nanometer. This is my formula. Lambda normal minus delta lambda is equal to delta lambda. From here, 10,000 minus 390 is equal to 10,000 minus, this is so important, minus this, delta lambda 1 is equal to 9,060 nanometer. Okay, what will this electron motion forms velocity for involving this 410 nanometer hydrogen line and visible light band? Delta lambda normal divided by lambda normal is equal to electron motion form velocity divided by c, say 9,610 divided by 10,000. Okay, multiplied by the speed of light, electron motion form, that is 10,000 nanometer wavelength size, its radius. Electron motion form needs gaining near the speed of light 288,300 kilometer per second. Certain velocity, electron motion form, that is 10,000 nanometer wavelength size here. This is its graph, okay. Now, think of another object's smaller electron motion form. Lambda normal to, it was, remember, 2,500 nanometer wavelength size, okay. And what will be its continuous spectrum? That continuous spectrum produced by this 2,500 nanometer wavelength size electron motion form group, totally interfered, okay, 2,500 nanometer wavelength size electron motion form, it will involve visible band, okay, like this visible band, and it will involve 410 nanometer hydrogen's line. Okay. Now we will think of. This means my same formulas, my same method I will apply now. 390 nanometer is shortened wavelength. Okay. Lambda normal 2 minus delta lambda is 390 nanometer. And what will be delta lambda? Delta lambda is equal to 2500 nanometer minus. Okay, now 2500 minus 390. Yes, delta lambda here, 2 for this, will be equal to 2110 divided by lambda normal 2500 is equal to, this is electron motion forms velocity. We need to involve this 410 nanometer wavelength hydrogen line, okay, for coincidence with that, for coincidence with visible light, okay. Then divided by, yes, multiplied by 300, yes, its electron motion forms velocity will be 200 and 253,000 kilometer per second. What was its velocity? Remember, wait a moment. Minus divided by 10,000 multiplied by speed of light. 288,300 kilometer per second electron motion forms velocity for this graph. For this graph, this electron motion form must gain 253,200 kilometer per second velocity. Don't forget this. Okay, I will write this. 288 and 300 kilometer per second, and another one